Hello, math humans. We're going to do 1.7b today. We're going to be talking more about transformations. Our objectives are that today we're going to talk about non-rigid transformations, which means we're going to have a change in size. And that means specifically that we're going to talk about vertical and horizontal stretch and shrink. All right, so from yesterday, I want you to remember that outside the function is going to be a vertical change, and inside the function is a horizontal change. Alrighty, so those are the two critical pieces that we need to remember from yesterday. So let's say I have a function h of x, and it's going to be a times f of x. Notice it's outside the function, which means this is a vertical change. And if a is greater than 1, then this is a vertical stretch. And if a is less than 1, that means that it is a vertical shrink. So the nice way to illustrate this is to talk about sine functions, because it's just easy to see what happens when you change it. So let's say this is my original function. Well, if I stretch it, the endpoints will stay the same, but the graph gets taller. And if I shrink it, then again the endpoints stay the same, but the graph just gets shorter. That's kind of fun looking. Alrighty. So then the other situation would be h of x is equal to f times a of x. Notice now that the a is on the inside of the function, so this is going to be a horizontal change. All right. If a is greater than 1, that means that this is a shrink. So before you think that I've lost my marbles, remember that we talked about any time you have things on the inside of the function, it's the opposite value. So if it's greater than 1, we're going to do the reciprocal, which is the opposite mathematically. So it's going to be a shrink. And so then if a is less than 1, the opposite would be a stretch. And I think the easiest thing will be to do some examples. And then I did have, just write that down so you can get that stuck in your brain. All right, so let's just start doing some examples. So the first example, we want to, I'm just going to tell you that the parent is going to be y is equal to the square root of x, continuing kind of that example from yesterday. And so I want you to, what do I want you to do? I want you to identify, I was trying to think of the right word, identify the transformations. All right, so the new function, g of x, is going to be x over 4, and I'm going to rewrite this as the square root of 1/4 times x, because then I think it's a little bit easier to understand what's going on. This is inside the function, which means it's a horizontal change. And remember, it's going to be the reciprocal, so this is actually a stretch. Oops, you have to qualify it. It's a horizontal stretch of 4, because remember, it's the reciprocal value. Okay, example 2, we just bust through these pretty quick, and we're going to keep using the same parent function, and we're just going to continue to change it a little bit. So what if I have g of x is equal to 3 times the square root of x? So again, a parent function is this. This is outside the function, so this is a vertical change. So this is a vertical stretch of 3. Alrighty. We move right along to our next example. What color? Let's go to orange. So this is example 3. And again, I'm going to use the same parent function. So g of x is equal to the square root of 3x. This is inside the function, so it is a horizontal change, which means it's the reciprocal. So this is a horizontal shrink of a third. Okay, anything that's inside the function is going to either be the reciprocal value or it's going to be the opposite sign. All right, so now what I want to do is I want to combine, so this is going to be example 5. Actually, this is example 4. Let's do one more and then I'll start combining them. What if I had g of x is equal to 1/2 square root of x? Okay, again, this is outside the function, so this is a vertical change, so that means that this is going to be a vertical shrink of 1/2. So now what I would like to do is start combining all of the things that we learned from yesterday and today. So for example 5, sorry, sometimes my brain gets ahead of my mouth. All right, so I'm going to have g of x is equal to a negative 2 x minus 7 quantity squared plus 3. So this has lots of different things. The parent, f of x, would be x squared. We have a lot of different things going on to x squared. Remember that when we report transformations, we go left to right. So I'm going to circle the individual things that we have going on. There's the first thing, there's the second, third, and fourth. So the first thing that I have going on outside the function is a reflection across the x-axis, which means that it's turning this cute little parabola upside down. It has a vertical stretch of 2. You always have to qualify how much is changing. It's going to go 7 units to the right. Remember, this is inside the function, so it's going to be the opposite sign. And then it's going to go up 3 units. And those are the transformations that happens to that cute little function. All right, now let's do the next example, and it's actually your last example. I lied, second to last. So this one is going to be g of x is equal to square root of a negative 3x plus 9 minus 4. Now this one is tricky because of the inside. And remember that you have to factor first. This will be the absolute most common mistake that you will make. So I'm going to rewrite this as g of x is equal to a negative 3 times x minus 3, and then minus 4 stays outside. Now I can talk about my transformations. This is 1, 2, 3, and 4. So I have a reflection across the y-axis because it's inside the function. I have a horizontal shrink. Remember, it's the reciprocal of 1/3. I'm going to move 3 units to the right, and then I'm going to go down 4 units. So it's important, I guess you can't see most of that, sorry, my bad. Really important to remember anything that happens on the inside of the function is always going to either be the reciprocal if it's multiplied or the opposite sign if it's just added or subtracted. This is critical. If you don't factor, you would have said that it had moved 9 units when in fact it really only moved 3 units. All right, now I have one more example for us and then we're done. Last little example. So I'm going to have g of x is equal to a negative 3 absolute value 2x plus 7 minus 5. Woohoo! Look at all that fun stuff going on. All right, your parent is going to be y is equal to the absolute value of x. So in this particular function, I need another color. I have 1, 2, 3, 4, 5 things going on, but remember, before I can do anything, I have to factor first. Super, super important. So the negative 3 is going to stay outside. The 2 is going to get factored out inside, and I'm going to get x plus 7 halves. And it's okay if it's a fraction. Fractions are our friends. We like fractions. Okay? So now I can talk about, I have a reflection across. You always have to tell which direction. The x-axis, because it's outside the function, so it's a vertical change. I have a vertical stretch. I can't spell today. Stretch, of 3. Okay. Remember that the negative is the reflection. It has nothing to do with the stretch or shrink. Then I'm going to have a horizontal shrink opposite of a half. I'm going to go left 7 half units, and then I'm going to go down 5. Alrighty, so make sure that all makes sense. If not, we will answer questions when you come to class tomorrow. That's it for today. See you soon.